Hey everybody, welcome back to another college algebra session. This is part 1 of section 7.1.7, linear inequalities and absolute value inequalities. We won't do those until the second half. Right now, today, we're going to concentrate on linear inequalities, but before we can do that, we need to talk about the concept of interval notation. Okay, so today in this section, we're going to do interval notation and we're going to solve linear inequalities. We are not going to worry about intersecting or unioning intervals. All right, that's not in the scope of this course. Okay, so we're going to do these two things here in this first section, and we'll do these last couple of things in part 2. All right, so solving an inequality, when it's a linear inequality, it's the exact same process that we use when we're solving an equation. So if I want to solve 2 plus 3x equals 5, what do? I isolate the x's, right? I get the x's all by themselves, and then I divide and solve for x. Okay, we're going to do the same thing if you have an inequality. The only difference is if you multiply or divide by a negative number, that inequality switches. Okay, you got to remember that you flip that. All right, we'll talk about that in a minute. So again, before we get there, interval notation is the way that we're going to express our answers. An open interval from A to B, it looks like a point. Be careful. You have to know the context. Okay, this is the exact same symbols as you use for a point x, y, but that's not what we're representing right now. All right, and so this represents all of the numbers between A and B, not including A or B. This is set builder notation. A closed interval with what we call the square brackets here, all right, includes the endpoints. So that includes all the x's between A and B and also A and also B, all right? So there's only two different numbers between these two expressions. This is all the stuff between A and B not inclusive, and this is all the stuff in between A and B including A and B, okay? We also have the infinite interval. We will never include the endpoints for an infinite interval. The infinite side of it, we'll never include that because you can't equal infinity. Infinity is just a representation. It's not actually a number, right? Infinity, this sideways 8 looking thing, that represents infinity. And that represents growth without bound, or in the negative direction, decrease without bound. All right, so if you want to write x greater than a, you write a to infinity. If you want to write x less than or equal to b, you write it negative infinity to b. Okay, the big thing about interval notation, when you write a comma b, doesn't matter if it's closed, open, whatever, a must always be less than b. You will never write something like this, 5 to 2. You'll never do that. Okay, because that doesn't make any sense. Okay, so you got to make sure you always put your first number smaller and your bigger number second. Okay. So, and again, parentheses are always used with infinity or negative infinity. So we're going to actually present multiple ways of expressing the same thing. Not only do we have interval notation, but we're also going to use graphing as well. So there's 3 ways to represent the same thing. Okay, here's interval notation right here. 1 to 3.5. Here's set builder notation. All the x's so that 1 is less than or equal to x is less than or equal to 3.5. And then in between 1 and 3.5 on this graph with, again, these closed brackets. Some textbooks will use a closed circle instead. Okay, but I'm going to use closed brackets or open brackets. Here they would use an open circle and go that direction. Okay, so if you've used that before, I will accept it, but just know that my math lab's looking for this kind of notation here. Okay. All right. So if we're looking to solve an inequality, it can be one of these 4 forms, and we, again, basically do the same thing we did before. We isolate the x's, then we divide. The only thing you got to remember is that if you divide an inequality or multiply an inequality by a negative number, the direction of the inequality symbol is reversed. And for me, that's really easy to remember because when you divide by a negative, it changes the sign of your number. So if you divide by a negative, it changes the sign. the inequality sign. Okay, so let's work a problem here. Solve and graph the solution set. So we've got 2 minus 3x is less than or equal to 5. We want the negative 3x by itself, so that means we got to subtract 2 from both sides. So we're going to get negative 3x, don't forget the negative sign still there, less than or equal to positive 3. And then what do we want to do? What we want to do now is we're going to divide by this negative 3. But if I divide by negative 3, it changes all the signs, including that one, right? So negative 3 divided by negative 3 becomes positive x. 3 divided by negative 3 becomes negative 1, but this sign becomes greater than or equal to. Okay, and the reason that happens, right, think about it, 2 is less than 3, right? But negative 3 is less than negative 2. When you begin to get negative, the more negative you are, the smaller you are. And so that's one way to think about it. But like I said, the easiest thing for me to remember is if I divide by a negative, it changes the sign of my numbers. So it's going to have to change the sign here, also the inequality sign. Okay, so now, like we've been doing, we want to write this as a number line, draw the number line out. Okay, you really only have to put negative 1 on there. As far as I'm concerned, if you want to put other ones on there, that's great. And then because it's less than or equal to, greater than or equal to, excuse me, we have that closed bracket and then just shade it in. You don't have the ability to make it super nice like the textbook does, and so just shade it in. That's good enough for me. Okay, using an interval, how do we write that? We write that negative 1 to infinity, never including infinity, but including the negative 1. Okay, so 3 ways to write your answer. Here's one way to write your answer. Here's a second way to write your answer. Here's a third way to write your answer, and you're going to be asked for all of those ways. All right, so we're going to give you a second problem. You're going to go ahead and pause the video, work this problem on your own, and then see what you get from there. Okay, so take a minute, pause the video, and solve this problem, giving me the answer again in those 3 ways, giving me the solution on the number line and also solution using an interval. Okay? All right, so how did that go? First steps here, we got a little bit more complicated problem this time. We're going to collect all of the x's to one side, so we're going to subtract 4x on both sides. Right, that gives us 8 plus 3x less than or equal to 5. Now we're going to collect all of the constants on one side, so we're going to subtract 8 from the other side. Here we get 3x less than or equal to negative 3. And now when we divide by 3, 3 is not negative. To the right you're going to get a negative answer, but it doesn't flip the signs because we divided by positive 3. That keeps all the signs. Here's your answer. X is less than or equal to negative 1. What does that look like on the number line? This time we have a negative 1 here, and it goes this direction, shaded to this side. And of course, negative infinity to negative 1, including negative 1, is your solution set written as an interval. Okay? So again, all those ways are great ways to write your answer. I'm totally fine with that. And come back for the second half of section 1.7 video. We'll talk about compound inequalities and also inequalities with absolute values. All right, thanks.